So we've covered a lot of ground in terms of conceptual ideas relating to linear regression and bias variance trade-off. I just wanted to give a few practical remarks before finishing today's lecture, and those are mainly remarks with regard to implementations in Python and how we can actually practically kind of fit models such as the ones which we discussed today. So firstly, you should probably by now know more about how to manipulate data in Python. You have learned this in previous courses. So as you know, most of the data manipulation in Python is done in NumPy, maybe not directly by you. You might be preferring using Pandas data frames, but under the hood, actually you will use NumPy there, which is just a very efficient way of using data structures or data frames in Python, which basically underneath uses a more C++-like way of actually laying out the data in memory. And actually, if it's, for example, a data frame of float numbers, which actually uses this type of data when laying it out, whereas a kind of Python number is just a whole structure which has a lot of additional information which we do not really want to use in this data frame. So long story short, it's a very efficient way of manipulating data, and because underneath we had everything in C++, and a lot of the ways of manipulating the data, a lot of the linear algebra computations are actually optimized routines in C++, it can actually be quite fast. So even though we are using Python, we can manipulate data quite fast because a lot of the stuff uses C++ code underneath. And it's a nice way of manipulating data. Pandas data frames are very easy to work with, and you hopefully got familiar kind of how to slice and dice, how to subset the data, such as kind of array, just how I select all columns and the last element is the first element or the first 10 elements. So hopefully by now you have some better idea of how to do that. And also you should be able to use some of the functionalities to summarize data. For example, you should have seen things like df describe, as df is your data frame, or look at the correlations of different predictors, or just plotting everything you see in the data. So often before actually doing any of the analysis, before we start doing before we start applying machine learning, first we want to do some descriptive analysis of the data, summarize it, investigate it, see whether it's all fine. So that's something you should hopefully be familiar with by now, and you can probably also work with functions such as merge and join if you want to combine different data sets, or group by, unstack and apply if you want to do various manipulations, some of which we will be seeing as we go along in the practicals of the exercise session. So assuming that you know how to manipulate the data, the next question would obviously be, how do we fit models? How, for example, do I train or fit a linear model? How do I fit a logistic regression like we get to know tomorrow, or lasso, which we get to know on the third day? So all those will be done using a package which is called sklearn, which is a basic machine learning library in Python. And we will be using some other methods as well. For deep learning, we'll be using TensorFlow, but basically most of everything which is not deep learning will be based on sklearn. There are a few other packages. For example, next week we'll talk about boosting. Actually, there's boosting in sklearn, but it's not a very good implementation. There's another one by Microsoft which works better, but those are kind of exceptional cases. For as a generic remark, if it's not deep learning, you will most likely use the implementation from sklearn. And the nice thing is that it's very intuitive. All the models we will be using have a kind of very similar syntax. So first I have to import it, like linear regression, I just import linear model, or from sklearn I import linear model, and then I define a model to be, say, a linear regression, or it could be something else. Maybe I want a regression which has a different loss function, like the absolute value. So I can define it slightly differently, but everything which what follows will be the same. Now I have my data. I have train data and test data, and how to split it we will learn in the tutorial as well. But assume we have done it, actually now fitting the model is always done using the command fit. So if I have a model, I will just do model fit. I give it its supervised learning, so I will give it the predictors, X train, and I will give it the labels, Y train, and now it will just fit this model, and effectively the fitted values will be now part of this model class after fitting, and after I fitted it, it can now run predict. For example, now if I have my holder data as X test, I can now just run model predict X test, and I will get the predicted value Y test. And this is a very generic syntax, so this will be always the same. So it doesn't have to be linear model. Basically all I have to do is change this initial bit here. I could just plug in a different model, but everything else will be the same. Model fit, model predict, this will all be the same. The way how I split the data will be exactly the same. So now it's a nice way in the first tutorial for you to play around with this, apply it in simple cases of linear regression, where at least you have some familiarity before later we will actually be going to more complex models. But the basic idea is it will always follow the same recipe going forward.